Hi everyone. Today we'll be solving a problem from GE Advanced 2026 Physics section. It's a very simple problem. So let me write down the electric field vector. It is linearly polarized in the x direction. Now I'll compare the argument of the sine function with the general expression for the phase of a plane wave. This way I can obtain the wave vector and angular frequency. No, just the wave vector. Right. And I know that this is just kx, ky, kz. Similarly, r is x, y, z. From this comparison, I obtained that the wave vector k is 3j cap plus 4 cap k. This might actually be confusing, so I will rewrite the unit vectors. I'll write this as 3y cap plus 4z cap. Now that should be fine. Okay, so the first question, it's asking me the direction in which my wave is traveling. Okay, so before that, let us find k cap, shall we? It's just vector k over its magnitude, and the magnitude is just 3 square plus 4 square. K cap is that's 5, so 1 over 5 times. Okay, cool. So for questioning, you might be tempted to answer that k cap is the direction of propagation, but that is not always true, and I'll tell you why. Okay, so we know that the phase is constant, correct? Oops, yeah, the phase is some constant c. Now I'll just take the time derivative on both sides. I do that, this becomes 0. This is omega. So standard derivative rules apply to dot product. Oops. Yeah. So I end up getting k over dt dot r dot k dt omega. Cool. Just make more space. No, let me do that again. Yeah, this is fine. Yeah, so this is 0 because obviously your wave vector is time independent. Uh, I made a small mistake. So sorry about that. This is supposed to be K here, and this is supposed to be R. Right. And let me call this V. Your velocity vector. Now, what is this V? So V describes the velocity of my wavefront. So it is in fact my actual direction of propagation. And because the wavefront propagates normal to itself, and the normal vector to constant phase plane waves is the vector k, right? So thus my velocity vector is parallel to k. What I mean is v is actually say some v, and it's in the k direction, right? So now my k dot v ends up giving me v and v k hat dot, and that's another k hat. Yeah, this is the magnitude. Yeah, so it's in fact minus omega over k. Perfect. So my vector v, right? It's and let me write it like this: minus k hat. So the direction in which my wave is propagating, it's in fact in the negative k hat direction, which means option A is in fact, let me open a new page. Option A, which says that the direction of propagation is actually true. Let me tell you another simple trick to answer such problems quickly. So, if your face, right, has plus omega t, right, so the direction in which your wave is propagating would be in the negative k hat direction. Whereas if it was minus omega t, it would be in the plus k hat direction. This is the sign. This is the usually the sign convention in most uh, books, university textbooks, for example. Anyway, moving on to question B. They're asking me the magnitude of wave vector. I've already determined it. What I got was 5 meter inverse, whereas they've said it's zero point 0.5, which is incorrect. Okay, and they ask me value for omega, the angular frequency. It's just c times magnitude of k. Okay, how did I get this? Fine. This is just 2 pi times frequency, and that can be written as c over lambda, and 2 pi over lambda is the magnitude of my wave vector. Perfect. And the value of c is given. This also we just determined. So it's 3 times 5, 15, 1.5 times 10 power 9, and second inverse. So option C is correct. Okay, final question. They're asking me the magnetic field. Alright, let's do it. So I know that magnetic, oops, the expression for the magnetic field vector is uh, vector k cross E over omega, or k hat. Right. So this works for vacuum. Cool. Let me just go ahead with this one. Okay. So you must be familiar with the you know unit vector cross product rules. So if it goes clockwise, for example, x plus y would be z, but if it goes anti-clockwise, so cap cross cap would be minus y. Yeah, this is something that you all should be aware of. So let me just copy the expression for the electric field and I'll write down K. So K was 3 y cap plus 4 z cap, right? Cross this. Oops, there isn't enough space. Let me, yeah, perfect. Over omega. What is the option? Okay, it gives me an answer in terms of C. So I will also write it in terms of C. I think we should have gone with the expression that I erased. Would have been very simpler. Either way. Why isn't this moving? Yeah. So omega was just C times magnitude of K. So phi C. All good. Phi C, right? Phi C. And area here x cap. So yeah, so 1 over 5, oops, 1 over C, let's just look at uh, E naught over C. So y cap cross x cap would be minus z cap minus z cap sine its argument. Oops, I forgot the 3 minus 3. Perfect. And z cap cross x cap is y cap plus 4 cap again sine same. Oh, but there's a 5 here also. Okay. Yeah, the options don't match. There's an additional 5 which comes in the denominator, which is not accounted for. So yeah, option D is also incorrect. Hmm. Yeah, that's it, guys. Thank you. I hope I didn't make any mistakes. This is a very straightforward and simple problem. I'll be coming up with more such videos. Uh, J Advanced, J Mains, GATE, IIT Jam. Yeah, stay tuned. Bye bye.